Okay, in the last video we reached to this point. I draft these three equations. One is this, one is this, and one is this. And I separately explain the meaning of each of this term, like what is Ri, what is this capital R, and what is this Ri prime means. What is this velocity Vi means, what is this capital V velocity means, and what is this Vi prime means. So I'll not explain it again. Now the total angular momentum of the system can be written as the total angular momentum of the system is the total angular momentum will be the vector sum of the angular momentum of individual particle. Okay, so the total angular momentum will be equal to sum over I Ri cross Pi. But we know that momentum P, which is equal to mass times velocity, momentum of ith particle will be equal to mass of ith particle times velocity of ith particle, and we know that. So I will replace this Pi by this term. So we have this L, which is equal to sum over I. We have Ri cross Pi is basically Mi times Vi. Now we know that Ri is given by this relation, which is R plus Ri prime, and Vi is given by this relation, which is V plus Vi prime. So I will replace Ri by L is equal to sum over Ri by R plus Ri prime, okay, plus into dot product, cross product of Mi, and we have Vi. Vi is basically V plus Vi prime. So our total angular momentum is now equal to sum over I. We have R plus Ri prime, okay, and then we have this cross product. We have Mi into, now V, capital velocity V, and capital velocity V is basically represented by this R, capital R dot. So here I will replace it by R dot plus, and Vi prime is basically equal to Ri prime dot. So I replace it by Ri prime. Now here I will apply this R cross product with this one, and then this cross product with this one separately. So we have sum over I, and we have this R, and then we have cross product of Mi into R dot plus Ri prime dot, okay, and then we have plus, I will apply cross product with this one. So we have this Ri prime cross, we have this Mi into R dot plus Ri prime dot. Now I will apply this R to each term individually. So we have this summation over I. This summation is overall from here to here. So we have this summation, and we have this R cross Mi into R dot, capital R, and then we have this plus R cross Mi, and we have this Ri prime dot plus. I will apply this Ri prime to each term individually. So we have this Ri prime cross Mi into R dot, and then I will apply it to here plus Ri prime, okay, cross Mi Ri prime dot. I will apply this sum to each terms individually. First I will apply the sum to this one. So we have this L, which is equal to sum over I Now we have this mi, so sum is over I, so we have mi. I'll bring this mi first, and we have left with r cross r dot. Okay, then I apply my sum to this term, so the summation is over I. We have r cross mi into ri prime dot, and then I'll apply the sum to these terms. So here we have this sum over I. Now here this mi is here, so I bring this mi to this side, so we have this mi ri prime cross r dot, and then we have this plus. I will apply the sum to this one, so we have this sum over I. I will bring this mi to this side first, so we have mi ri prime cross ri prime dot. So this is the total angular momentum of the system of particle. Now I will explain, each term individually. So first consider the second term. Consider the second term on the right hand side of equation A. This is equation number A. So consider this term, the second term, and the second term is sum over I r cross mi ri prime dot. Okay, so this will be equal to sum over I. Okay, we have this r cross mi. Mi is this, and we have ri prime dot. We have ri prime dot, and from this equation we have, if I calculate the value of ri prime dot, then this will be equal to ri dot minus r dot. So instead of ri prime dot, I will put ri dot, no sorry, yes, this is ri dot. Am I right? Yes, this is ri dot minus r dot. Okay, now this will be equal to, I will apply this sum to this one first, and I will write it like this: sum over I. This is mi. I can write it as like this: r cross mi ri dot. And then we have this term. I think there is a problem with this term. I have to check it first. We have this r cross, the second term is mi ri prime dot. So yes, this is right. Okay, and then we have minus r cross, we have this mi into r dot. Okay. Now I will apply the sum. So here we have this sum over I. We have this r cross mi or I dot minus I have this sum, and we have r cross mi into r dot. Now here I left with this term. This is equal to, so r is, there is no sum on this r, so I will bring it outside of this summation. So cross sum over I mi into r I dot, oh sorry, so we have this is equal to, this r is without summation, so I will keep it outside, and we have this cross, and sum is here mi or I dot minus, we have this summation is only on this mi, so here we have, I can write it as r cross r into summation over I mi. Now we know that this is from the second term, which is sum over I r cross mi r I prime dot, is this one. Okay. Now we know that the position of the center of mass is given by sum over I mi r I over sum over mi. Now this is the total mass, so we replace this sum over mi by capital M. So we have r is equal to sum over I mi r I, okay, over M. I can write it as like this, m r is equal to sum over I mi r I. If I take the time derivative, then the only variable quantity is this r here, and the only variable quantity is this r I prime here. So if I take the time derivative, then this m r dot, time derivative of dr over dt, which is equal to r dot, will be equal to sum over I mi r I dot dri over dt, which is equal to ri dot. So I replace this, sorry, this is ri dot, so this is mr is equal to sum over I mi ri. So if we have dot here, then the dot will be here. So I have to replace this quantity, which is here, is this one, yes, this one, by this one. So here we have this summation over I r cross mi r I prime dot, okay, this quantity is equal to, now this is r cross, we have mi r I prime r I dot, and we have mi r I dot is equal to m r dot, m r dot, this is capital M, and we have this r dot, okay, minus, we have this r, and this is r dot, okay, because we have r cross mi r I dot, mi r I dot, minus r cross mi r dot, so r cross r dot into mi. Now here we have r cross r dot into m. Now because sum over I mi will be equal to the total mass of the system of particles. So it means that this is equal to r cross m r dot minus r cross this r dot, sorry, so m is, I will bring m to this side, m r dot. Now this will cancel with this, so this is equal to 0. So the second term, which is r cross mi r I dot is equal to 0. So this term will become 0 here. So instead of this I will put 0 here. So we left with 3 terms now. Now I will consider the third term, this term. I'll consider the third term, which is mi or I prime cross r dot. So next consider the third term, which is the third term in this equation A is sum over I mi or I prime cross, we have this term R, capital R dot. Okay. Now we know that Ri prime is basically, because we know that Ri is equal to R plus Ri prime, okay, from our previous equation. So it means that Ri prime will be equal to Ri minus R. So this will be replaced by sum over I mi. Instead of Ri prime I will put Ri minus R. Okay, and then we have cross R dot. Now this will be equal to, I will apply this cross product to each term individually. So we have this sum over I mi Ri cross R dot. Okay, and then we have this term minus sum over I mi, and we have this R cross R dot. So this term will be equal to, I will rewrite it again in clear form. We have this mi Ri cross R dot minus sum over I mi R cross R dot. Now we know that mi Ri is equal to sum over I mi Ri is equal to m R. So instead of this I will replace it by m R, and then we have cross R dot minus, this is sum over mi is basically, and we know that sum over I mi is equal to the total mass. So here we have this total mass m, and then we have this R cross R dot. Okay, so this will get cancelled with this one. So this term, which is sum over I mi or I prime cross R dot is equal to 0. It means that this term will also become equal to 0. So equation A will reduce to equation A. Now using this value, then equation A will reduce to L, which is equal to sum over I. We have mi R cross R dot. Okay, and then we have plus sum over I. We have mi or I prime cross or I prime dot. This is equation A now, which is reduced to this form. Now here I will write L is equal to sum over I mi. So it means that this R cross R dot is constant, so I'll keep it outside of the summation. So we have this R cross R dot, and then we left with this sum over I mi. Now next we have this plus this sum over I. I will write this Ri prime first, and I bring this mi to this side cross mi or I prime. Now this is equal to r cross r dot, and this sum over I mi is the total mass, so I will replace it by capital N, plus sum over I, we have this r I prime cross, this is mi r I prime dot, yes, this is dot, and this is equal to, this is mass times velocity, which is equal to momentum, but momentum of ith particle, but ith particle of momentum of ith particle with reference to center of mass. So we have pi prime here. I can write it like this, r cross, I'll bring him to this side, m r dot, okay, and then we have plus sum over I r I prime cross pi prime. I can write it as like this, r cross, this is mass time velocity of center of mass, which is equal to momentum of center of mass, okay, r cross p, plus, now this is ri cross pi, we know that angular momentum is ri cross pi, sum over I, but this is, there will be a prime here, so this will be angular momentum L prime, so I will replace this by L prime. Now we have the final expression here. The final expression is the total angular momentum now contain two terms. One is r cross p plus in this L prime, where p is, where we replace p by m r dot, and this is the linear momentum of center of mass. This is the linear momentum of center of mass. So if this is the linear momentum of center of mass, then this term r cross p, linear momentum times this r, is the angular momentum of the total mass concentrated at the center of mass, about point O. Now this p is replaced by this is the linear momentum of the center of mass, so it means that this r cross p, because we know that L is r cross p, so that this term is the angular momentum of the total mass concentrated at the center of mass about point O. Now next, L prime. What is L prime? L prime is basically r I prime cross pi prime, sum over I, and let's represent the angular momentum of the system about its center of mass. So this proves the theorem, because the theorem has two kinds of momentum. It tells that the total angular momentum, here the total angular momentum is equal to the sum of the angular momentum of the total mass concentrated at the center of mass about point O, which is this one, plus the angular momentum of the system. So sorry, I will explain it again. Let me check this, it's clear now. So this is the proof of the theorem, because this theorem tells us that the total angular momentum, which is this one, is equal to the sum of two momentum. One is the angular momentum of the total mass concentrated at the center of mass about that point, which is this one. This is the angular momentum of the total mass concentrated at the center of momentum about point O. It is this one, plus another term, plus the angular momentum of the system about its center mass, which is this one, because this is the angular momentum of the system about its center of mass. So this proves the theorem. So I hope you understand this theorem. In the next video I will move towards the energy of the system of particle. Thank you.